In this lesson, we will solve an application problem involving compound interest. Compound interest. Compound interest is the interest that's calculated on the principal, but plus any previously earned interest. So in other words, if you put a certain amount in an account, after a certain period of time, it's going to earn interest, and that interest is going to be added to that principal amount that you put in, and then it's going to earn interest during the next period based on that amount. So here's what I mean. Here's an individual who deposited $1,000 into an account at a 2% interest compounded annually. So every year, annually means every year. Every year, it's the interest on this account is going to compound. What we mean by compound is it builds on each other each year. So to find the interest that you're going to get for the first year, recall that interest I equals PRT. P, the principal amount put in, was 1,000. The rate on the account, remember, was 2%, so to write it as a decimal is 0.02, and 1 means the time, so here the time is for 1 year. This is annually. So that's going to give you $20 interest earned on that. So you add that to the money you already put in, the 1,000, and you have 1,020. So year 2, now the interest that you're going to be earning is going to be based on your new balance. Your balance in the account is $1,020. So then you use that to calculate your interest, 1,020 times the rate times the time. That gives you $20.40. And so now your new balance is going to be $1,040.40 because 1,020 plus the new earned interest that you earned gave you the $1,040.40. And it just continues on and builds itself. So let's say after 5 years, we see here that the account, after 5 years of compounding it at a 2% interest, that amount of 1,000 grew to $1,104.08, and that is compound interest. Interest plans. Now in the previous problems, the interest on that particular account was compounded annually, which was once a year. In other words, every 12 months. But here's some other plans there. Semi-annually, it's going to compound twice a year, which is every 6 months. Quarterly is going to compound 4 times a year, which is every 3 months, and so forth. Okay, so just make sure you keep in mind these different time periods in which the interest on the account can compound, because that will certainly help you in solving problems involving compound interest. Compound interest formula. In this example, we're asked to find the present value that will grow to $5,000 if the interest is 3.5%, compounded quarterly for 10 years. So here we're given 5,000 is going to, that's our amount that it grew to after a certain amount of years. So that's A. We're also given our rate, which is R. We need to turn that into a decimal. We're also given the number of times that it is compounded. Here it is compounded quarterly, which is 4 times a year, so N equals 4. And we're given the time. The time was 10 years, and that's T. So here's the compound interest formula. A equals P times, and here you're going to multiply that with 1 plus R over N raised to the NT power. So again, A is 5,000, R is 0.05, N is 4, and T equals 10. So all you have to do is simply plug those values into your scientific calculator. Don't expect for you to calculate that by hand, because as you see here, 4 times 10, that's 40. You would have to raise that to the 40th power. But yes, it's real quick and simple. Just use your calculator to make the calculations. You can do it in increments, do a little bit at a time. For example, you can calculate what's within the parentheses there. That's going to give you 1.00875. And then when you multiply the exponent, that's going to give you 40. And now you can, in your calculator, take that amount and raise it to the 40th power. But once you do the calculations, like I said, your calculator will do it for you. It's going to give you a value of $3,528.81. And what that means is that is the present amount or value that you would have to put in at this time, your principal, and then let it stay in the account for 10 years at a rate of 3.5%, and it will grow to $5,000. And there you have it, applying the compound interest formula. So in this problem, we're going to be finding the future value, what it's going to be down the road, down the line. So find the amount in a savings account at the end of 8 years if the money originally deposited is at $7,000 and the interest rate is 5% compounded quarterly. So here we're given the principal. This time we're given P. We're not given A. We're given P. This is what was put in, not principal. Our rate is 5%, which we're going to turn into a decimal. And N is 4, compounded quarterly. So, and T here, our time is 8 for 8 years. So we're going to plug in what we know into our calculator so that we can find out what that amount is going to be, or what it's going to grow to in this savings account after 8 years. Okay, so you want to go ahead and do that. All right. So let's see what you got. If we plug in all the values that we know and plug them into your scientific calculator, like so, can you tell me what value did you get? Is it A, B, C, D, or is it none of these? So if you did it correct, the correct choice should be B. When you round it to the nearest dollar, it will be $10,416.91. It will grow to in 8 years if $7,000 is deposited into an account at a rate of 5% compounded quarterly. Leave it in there. Don't touch it. At the end of 8 years, this is the amount you can expect. And there you have it, applying the compound interest formula.